Hello, my name is Rob Mitchell, and today we're here at Embedded World Nuremberg, and I am joined by...
Greg Sheridan with Octavio Systems.
Now, very quickly, just to mention, even though we're at the Avnet booth, Avnet is a distributor for your company, isn't that right?
Yeah, that is correct. They
Brilliant.
distribute our system and package products.
Brilliant. So, to start off with, could you just show us what it is that you've got as a demonstration here?
Yeah, so, we're Octavio Systems. We do system and package technology, system and package devices. So really what we have is kind of a showing of our different lines of system and package devices. We started off, this is our first device that we built. It's built around a Texas Instruments AM3358, but basically all of our devices integrate a processor, DDR memory, power management, and all the passives that go along with it into a single BGA package. So like this one right here, this is our ST MP1 based product as well. Again, you see it's a single, simple BGA, really easy to use, but inside of this is the processor, the DDR memory, the power management, and all the passives.
So on this one, you've actually got like the same kind of epoxy, not epoxy, is it epoxy or ceramic? What is it?
It is a mold compound.
Yeah, and so it almost looks like an integrated circuit on its own, but it's actually a package with lots of bits inside.
Right, exactly. Inside of the standard BGA package that you would see is all these 100 some odd components.
Right.
So the idea is to really make life simpler for people that are looking to use these technologies to develop their system.
And so in the case of a system in a package, what it is that your product does is, let's say you want to take the STM processor in this case, you'd have to have other supporting components with it.
Exactly.
But you're sticking it all into one package so it can be directly mounted onto a PCB.
Exactly. So we integrate the processor, the DDR, the power management, and all the passive components. So it ends up being like 120 components that the customer would have to design, layout, deal with the complexities of DDR routing, deal with the power sequencing, all that kind of stuff. We remove all of that, so they just have a known working module they can drop down and start doing their system design, and just basically get to market much faster. And that's even more true with the new product that we have just kind of released out, and this is a ZU3, an AMD Xilinx Z3-based system and package.
Now, I'm sorry to interrupt very quickly and mention that it's AMD Xilinx because Xilinx was recently purchased by AMD, or not recently.
Probably about a year ago.
Yeah.
They were purchased.
And Intel purchased Altera, wasn't it? So
that was a while. That was further ago. But we still kind of go Xilinx, but it's AMD Xilinx.
Technically speaking,
AMD Xilinx. But so this is basically a system and package for this, but this becomes even more. Even a bigger help to customers now because of the complexities that go on with developing an FPGA processor like this. So, normally if you were going to design this thing yourself, you'd have 13 different power domains that you'd have to design, sequence, do all that kind of stuff. Then you have the complexities of the high-speed LPDDR4 that goes into that as well. We remove all that for you. So this is a single 5-volt in. And
single 5-volt?
Single 5-volt in. Generates those 13 different power domains for you, actually gives you 2 different power domains that you can use external to your system, and we've integrated the LPDDR4 all in a package that's going to be about 60% smaller than if you were going to do it yourself. And then the thing that basically is just now available is what you see here. This is our reference design, our OSD ZU3 ref platform. This is the reference design for the ZU3. And really, like all of our reference designs, it's a completely open source reference design. So that means all the schematics, design files, software, everything you need to get up and running on this is available for free on our website. And because of the integration that the system and package provides, this is a 4-layer PCB that uses basically very low cost design rules.
The reference design.
The reference design is a 4-layer board.
Not your system in package.
Our system in package. This is like
more than that.
I mean, you can see the thickness. I think it's about 14 layers.
It's quite chunky. It's quite heavy, isn't it? Yeah.
Yeah. So basically, we remove the complexity that would normally be in the PCB. Right. There's a design like this with a discrete version that's basically 12 layers with some connectors on it to do the same thing we're doing here because of the integration of the system in package, you're able to do that same stuff in the 4 layers.
So one question I have is, what's the difference between a system in package and a system on a module?
Yeah, no, that's a great question. So at the end of the day, we are really trying to solve a lot of the same problems, right? With the, basically faster time to market, things like that, making the design easier. Where we differ is really the manufacturing technologies and the manufacturing techniques used. So we use IC manufacturing technologies instead of PCB manufacturing technology. So if you look kind of at this device here, you'll see, we use a lot of bare die. So we're using bare die and IC manufacturing techniques.
And then like your gold wires going straight to the...
Yeah, so that you've got the bond wires and stuff like that that are used. So that allows us to significantly reduce the size. So most of our products are at least 60% smaller than doing it discretely. We're also able to keep costs down and more in line with what you would see if you were going to compare it to discrete components and doing it yourself. Because we're using that IC manufacturing technologies, right? We kind of get that IC cost curve and pricing curve versus, SOM. So we support customers with volumes of 1 up to customers doing hundreds of thousands, right? Because it can be still cost competitive at those volumes.
So a quick question, this system in package here has quite a big heatsink on the top. What kind of power are we talking about for this kind of device?
Yep, so the ZU3 kind of standard, we're looking at about 5 watts. It can go up to 10 watts, again, really depending on the application. And then these guys over here, the TI processor and the ST processor are more in your 1 watt type range, yeah.
And what kind of applications would we expect to see this type of system in package?
Yep, so that package we're seeing a lot in kind of industrial control, industrial imaging. So also some medical imaging, medical space, secure connection, secure communications things. So anything that's kind of got some custom IP, custom algorithm, AI, right? Where you've got a lot of like
AI on the
AI edge type stuff, right? Because you can there's a lot of processors that have kind of those little AI cores. This one, can kind of do your own AI core in an FPGA fabric and really allow it to scale up in volumes. And
so this is integrating an FPGA as well?
Yeah, so this is based on the Xilinx ZU3 FPGA. Right. So basically what it has a quad-core A53s that run at 1.2 gigahertz, a couple of R5s, and then it has the whole FPGA fabric along with it. Yeah, this is a serious, very powerful device. So
so it gives the engineer the ability to not just create their custom software, but also have their custom hardware through the FPGA.
Yes. Exactly.
And so what would be an example of how how would you use that FPGA in those examples? Would it be something like a digital signal processor or something?
Yeah, so again, one of the areas where we see these types of processors used a lot is like software-defined radios.
Oh, exactly, of course.
Right,
yeah,
so they're doing, capturing just a lot of data, putting it through the filters and stuff like that are all done on here. Again, security and encryption, so they've got some custom security algorithms that they want to run on there, or again, just processing like MRI imaging and things like that. We have some MRI ultrasound type imaging where, it's a lot of that DSP type processing that's done on the inside.
Is there anything else you have to show us today that you might be releasing shortly?
Yeah, so we just announced today, we're really excited about basically continuing on our family and offering a new device built on the new Texas Instruments AM62 processor family. So it will be the OSD 6.2, and that will take the AM62 processor, which is again, new processor from TI with the quad A53s as well that runs 1.4 gigahertz, has all of the industrial protocols, interfaces, and things like that with it. It's really the successor, kind of the next step up from the product that we have with the AM3358, and it will do basically the processor will move up to LPDDR4 on that one, have the power management, and then what's real exciting for us is that this will be a product that we are going to offer some extra optional integration pieces on. So we'll kind of have our core product, that mimics kind of these, and then we'll also have the ability to add things in like small CPLD FPGAs for kind of configurable IOs and small buffers and things like that. Also looking at adding ADCs and real-time clocks, and then also looking at adding Bluetooth, low energy.
So it's very, very peripheral oriented.
Yeah, basically giving customers the options that they have to really still further integrate their system, remove more complexity from them, and still this very, very small package. Right?
And that is something I personally appreciate a lot, because those kind of things can be very complex to try and integrate into your own products. So if you can provide, you take the burden of the complexity in the design, so the engineer can focus about how their system works, as opposed to trying to design it in the first place.
Yeah, exactly. That's really been our focus from the beginning, is we say remove the tedious parts that don't really add value at the end of the day, right? Nobody cares.
Like the power cycling, for example. Yeah.
Nobody cares that you got the processor to work.
No.
They care what the processor can do, right?
Exactly.
So why spend your valuable engineering time getting this to work? Focus on what's going to differentiate your product, what's going to bring value to your customer at the end of the day.
Now, if an engineer out there wants to use your products, do they go to you directly, or do they go to your distributors?
We have a wide network of distribution. We also have our sales network throughout North America and Europe that they can reach out to, come to our website, or you can reach out to our distribution partners like Avnet, as well as some others that you can, again, find on our website.
That's absolutely fantastic. Well, thank you ever so much for taking the time to see us today.
Yes, no, thank you. Appreciate it.